Hi, good morning. My name is Sreedhar W. I'm an ICAO certified aerodrome designer with more than 25 years of experience in various international airports equipped with Cat 1 to Cat 3B lighting systems. Today, I'm going to discuss about the precision approach path indicator, which is well known as PAPI. The PAPI system is a visual guide slope indicator consisting of four light boxes arranged perpendicular to the edge of the runway. It projects a pattern of red and white lights that provide visual approach slope information to the pilot. We could see four lights adjacent to the runway, arranged at various angles, starting with highest angle nearest to the runway. First light is placed at 15 meters from the runway edge. Next one are placed at 9 meters equally. When it is in correct approach angle, it shows two reds and two whites. When it is too low, it shows all red. Harmonization. Runways equipped with an ILS, it is desirable that there be harmonization between visual and non-visual approach aids. The difference between the position of pilot's eye and the position of the aircraft glide path antenna creates difficulty in achieving this goal. In previous slide we said ILS. What is ILS? In the field we have two equipment, one is localizer, another is glide path antennas. Then in onboard, it means in aircraft, you have a device which monitors this. Localizer gives the guidance for the center line in an approach. It shows where the runway center line. Whereas glide path, it shows the exact glide slope angle. As per the ICAO standards, it is 3 degrees angle. So while landing, pilots would be guided that uh, aircraft is landing in correct approach angle. We could see in this video how onboard equipment provides the guidance to the pilot. Just observe the aircraft. It is taking turn aligning. Now it is aligned to the center line. So it is getting near to the runway. Now it is in right approach angle. This is for the instrument. This is practical scenario. Various aircrafts video recording taken at same place, all are almost all passing through same approach angle. In previous slides, we have observed that PAPI and ILS should be harmonized. Why it is quite important? Here, as we can see, glide path is situated at one location and PAPI are situated at different location. Why? What is the reason? The reason being the ILS antennas in aircraft are situated at the bottom of the nose, whereas pilot is sitting and his eye path is somewhat higher than the antenna. So there is a difference between both. ILS is looking at the glide path antenna and angle is following with the glide path, whatever it is guiding. Whereas pilot eye path is observing the PAPI. So there must be proper harmonization so that when proper aircraft is in a proper glide path, pilot sees the correct uh, pattern of the PAPI lights. So how to achieve this one? Let us see in the next slides. Well, now we come to the critical point here, the important point, sighting of PAPI. What is sighting of PAPI? Why it is so important in airfield ground lighting design? The location of PAPI from threshold need to be calculated correctly. As we discussed in the previous slide, when runway is equipped with the instrument landing system, there must be harmonization as well. So first we will see how to calculate the location of the PAPI, in other words, sighting of PAPI. First, from ILS calculation, we will have the datum height. So in this example, we taken a calculated datum height has the 15 meters for that particular runway. That means from threshold, the height we are taken as a 15 meters. So putting a simple trigonometric calculation, V 15 cot 3 degrees is 286 meters. That means from here to here, it is 286 meters. Using the trigonometry, we calculated, mind it, we assumed that the runway is level runway. There is no slope, no upward slope, no downward slope. We assumed that runway is level, and from the datum height 15 meters, we applied the simple trigonometry and we got 286 meters a nominal PAPI location. Okay, in previous slide we have seen that datum height is taken 15 meters and we have applied the trigonometric function and applied to cot 3, 15 cot 3, then we got the distance between threshold to the nominal PAPI location. But as we discussed previously, that aerial aerial is under the nose, whereas the pilot is sitting above that. That means there is a difference between aerial location and uh, where the pilot eye is situated. So we have to find out the worst case scenario. That means in a given runway, in given aerodrome, what is the most demanding aircrafts? Generally, people misunderstand here. Most demanding means people will think that frequent flyers. No, mistake. A mature designer will never do that mistake. From the most, from the frequent, most frequent aircrafts which are being used in that runway, you have to pick what is the worst case of the distance between eye height to aerial height. So where we'll get this data? We know the aircrafts, we can find out from the fleet mix. Then we have to go to Aerodrome Design Manual Part 4. There is a table 6-1. In 6-1, you will get the data. So for the particular aircrafts which you have to consider in your design, you will be seeing that one. In this example, Boeing 737 and Airbus 300 is taken and the value is 1.7 meters. So what we did, that value we added to 15 meters. Here we added 15 plus 1.7, it becomes 16.7 meters. Again, gone back to the trigonometry. 16.7 cot 3 is equal to 318.6 meters. This is our new nominal PAPI sighting location. Now you see this slide. 386.6 meters, we have the nominal PAPI location there. Then we see the various angles of the PAPI lights. This is the farthest one, 2 degrees 15 minutes. Then third light is 2 degrees 45 minutes. Second light 3 degrees 15 minutes. Then the first one, nearest one to the runway, 3 degrees 45 minutes. Then see this one. Third light 2 degrees 45 minutes minus 2 minutes. What will happen? 2 degrees 43 minutes. 2 degrees 43 minutes, we use it for the calculating minimum high height to the threshold, MEHT. How we calculate? 318.6 tangent 3 degrees, tangent 2 degrees 43 minutes, we will get 15.1 meters, which is minimum eye height to the threshold. This is very important. In this slide, one notable thing is, as per ICAO Annexure 14, 30 minutes on course generally we select when we have to have the a better harmonization between ILS and PAPI. Okay, we have to maintain the minimum wheel clearance for the aircrafts which is used for that particular runway for which we are calculating the PAPI sighting. So in our calculation we have taken the Boeing 737, which is have to have 5.18 meters, and Airbus 300 9 meters wheel clearance is required. Okay, in this table we can observe for the Boeing 737 eye to wheel distance is 5.18 meters, then our MEHT minimum height to threshold is 15.1 meters. So if we deduct MEHT minus eye to wheel distance, you will get the wheel to the threshold how much is available. In this case 9.92 meters is available, and which is acceptable. Similarly for A380 we got 6.1 meters, whereas the minimum wheel clearance as per the ICAO Annexure 14 Chapter 5 Table 5-2 6 meters is acceptable. So whenever we do the calculation, whenever we achieve the PAPI sighting location, we have to verify whether minimum wheel clearance is achieved for the most demanding aircraft. Again, I reiterate, most demanding aircraft is not frequent flyer. It is from the wheel clearance point of view, what is the most demanding. So whether that much of clearance we have given or not, we need to ensure. So far we dealt with runway without any slope, but in practical, getting runways without any slope, either upward slope or downward slope, is not oftenly, uh, this is not the regular case, I mean to say. So in this example, in case if runway is upward, then does it have any impact on the PAPI sighting? Yes, it has. As we can see in this case, the nominal PAPI location from the threshold is shown here, whereas runway, due to the runway upward runway slope, that point is not on the top of the runway. So PAPI location has to be shifted. Let us see how to shift. In this slide, we will try to understand what are the stages we will be doing this one. First of all, the height at the nominal sighting location minus the height at the threshold we will be deducting. So that the variance, whatever variance we get it, that variance we shown here. Then with that variance, what we are going to do, we are going to calculate. So this is a new nominal location D1. Then we will be calculating, applying the trigonometry function, the horizontal distance. Then again the variance, this is D2. Again the variance between uh, uh, nominal site location and D1 is measured. Then what difference it comes, that difference is a vertical one. Then again we will apply the trigonometry. Then this is the final PAPI location. Why this slide we are shown so much of backward calculation, where graphically still we can see that uh, PAPI sighting angle and runway slope intersection point very easy to find. Why we did all these things? Because runway slopes are not consistent from threshold to uh, up to the PAPI location. Sometimes it would be 400, sometimes 500 meters, sometimes more than 500 meters. Then, then slopes also keep on changing. So then what happens? When the slopes are changing, we have to calculate very carefully by applying this trigonometrical way of doing the calculation. Okay, when it is downslope, similar calculation has to be done. See, nominal sighting location is shown in the graph. Then the difference between threshold height to nominal height we calculate. Then PAPI moves to D1. Then again the difference between D1 and nominal site location is calculated. With that difference, we will find the final location of the PAPI. So the notable point is when runway is downslope, the PAPI sighting goes farther from the threshold. It is quite uh, evident here, and it is very simple thing in this graph also we can see. Whereas in the previous slide what we did, when runway is upward, the PAPI compared to the nominal site calculation, PAPI location comes near to the threshold. So this is very important point to note. Let us go back to our original example in which we have the nominal PAPI location 318.6 meters. In this chart, we have the various levels of the runway at different locations, starting from the threshold until 320 meters in this example we are shown. So the level of the runway at 318.6 meters and the level at threshold, which is in this case 60.65 meters. The difference is 3.14 meters as we discussed in the previous slides. Then we apply 3.14 cot 2 degrees 43 minutes. 2 degrees 43 minutes is MEHD angle. So we get 66.33 meters. Then we move 66.33 meters towards the threshold because this is, as you see in the picture as well, this is upward slope. So when we minus 66.33 from the nominal PAPI value, what we get? 252.27 meters. It is a new location of the PAPI. Again, the same exercise what we did in the previous slide, we continue. The previous slide we seen that 252.27 meters, the new PAPI location, then that level minus 318.6 meters, we will find 0.71 meters. Then we apply the same formula, the value we will get it. Then we move the PAPI to the new location 267.23 meters farther from the threshold. This we have seen in the one of the slide when we were trying to find out the PAPI sighting when it is upward slope. If you have any doubt, please go back to that particular slide and see why in the first instance it has come near to the threshold, and again we gone back to the farther to the from the threshold. Same exercise we will be continuing, and until we get the value less than the zero point 0.3 meters, we will be continuing this exercise. In this case, the value we got it is 0.23 meters, that means less than 0.3 meters. So we need not to do further refinement of the PAPI sighting from the level point of view. So from the level point of view or otherwise grading point of view, the final PAPI location is 267.23 meters. Okay, one more correction need to be done here is correction due to the lens height. As you can see in the picture, PAPI lens is at 0.3 meters above from the uh, foundation. So we have to give the some correction for that. So that value will be deducted, and again we have to apply the trigonometric function. Then you will get the 6.32 meters for that lens height. Then we have to move the PAPI towards the threshold because it is upslope runway. So the final PAPI location would be 260.91 meters as we see on the slide. Okay, now we have the PAPI final sighting location. Now we have to back check whether it is meeting the requirement or not. How to do the back check? Back check calculation is very simple. Here 261 meters is the PAPI sighting distance, then apply the tan 263, 2 degrees 43 minutes, then you will get the 12.37 meters plus lens height 0.3 meters. Then the difference between the level, that means height at the threshold minus the PAPI PAPI sighting, location, runway, height. So when we minus these two, we will get 2.56. So 12.37 plus zero point 0.3 meters for the lens, then 2.56 meters, we got 15.23 meters. As we know, MEHD minimum high height to the threshold is 15.1 meters, and this value always should be more than MEHD to maintain the uh, minimum wheel clearances and all. That means when we do the back calculation, if this value is more than the MEHD, that means PAPI sighting calculation is done correctly. As we seen in the previous slide, uh, in some of the calculations they show this diagram also. As we see here, this is MEHD angle what we seen in the previous slide. Then this is PAPI height clearance. Then this is runway slope in angle. So if you want to do the calculation back check, D is equal to TCH, this is a clearance, divided by tan phi plus tan alpha. Tan alpha is nothing but runway slope angle. Tan phi is nothing but MEHD angle. This is also one of the way to do the back check. Then we come to the end of this presentation. If you feel that this is useful to the youngsters, please share with the upcoming AGL designers so that they would learn how to do the PAPI calculation, PAPI sighting calculation. And my name is Sreedhar Dabbiru, as I said in the beginning of the presentation, and this is my contact details. My phone number and my email ID is given. In case any youngster gets any doubt, please feel free to contact me at this email ID so that I will try my best to clarify any doubts. These are my credentials. Thank you very much. Thanks for listening. Thank you very much.